Welcome to the R learning session. Today we'll be talking about question number 2. Now, let's suppose that the manufacturer decides to accept the shipment if there is at most one defective part in a sample. Earlier, we had 5 defective parts in a sample. Now, it is reduced to one defective part in a sample. And the question asks, how large K have to be to ensure that the probability that manufacturer accepts the state unacceptable shipment is less than 0.1%. As above, a shipment is unacceptable if there are more than 5 defective parts. So, what we want to do is that when we take a sample, we can have at most one defective part even though sample has 5 defective parts. Now, we need to know that what is that probability. Now, let me think about it. What is the how should we go about and doing that? What we should know is that bigger the sample size, the lower the probability. The lower the probability of accepting the unacceptable shipment. So what we need to do is we need to look for a smaller sample size such that the manufacturer accepts the unacceptable shipment is less than 0.1%. 0.1. That's how it's going on here. So that's what's going on here. Now, what we need to do is we need to look at this. Well, let's start with our programming here. The first thing we need to do is we need to go ahead and say defective part run is equal to 1. And let's run this. It's running. It's run. And the defective part of shipment can be, now let's say there are 6 defective part of shipment, because it's more than 5 that we have rejected, so it's a defective shipment. So that's a defective part of shipment. There's 6, and the goods partner shipment would be around 94 because there are 100 parts, and we have to find out this. What would be the sample drawn? Now this is something we need to discuss. That is, let's for now let's do around 60. Now, for when you do, first of all, find a PMF of the hypergeometric mass probability distribution, and that is done by D hyper. This will give us the PMF or probability mass function of the hypergeometric distribution. And once we have that, we need to use that information to compute a quantile function, or we need to get a quantile value of this PMF. We need to get a quantile value of this PMF. Remember, this is also called critical value, quantile value or critical value. And for that, what we need to do is we will surround this G hyper with Q hyper, D hyper by Q hyper, and we need to add this function called defective part shipments and good partner shipment, like that. And once we do that, we can run this to get a quantile value, and it's 1 currently. And with this, we need to get the cumulative distributed function that's called P hyper. And for this, we need to do the similar thing as we did before. That is, we need to surround this with the P hyper, and this can be G hyper. Now just run this. It is giving me error. Why is that? Now let's see what's going on here. What do you think what's going on here? Can you tell me? Let's see. I think what's going on here is that we is correct, but I think we forgot to add enter here. Maybe if we do that, then that'll be get a correct value. Let's see. Yeah, it does give me a correct value. That is a problem here. Now, what it's saying is that the probability is 0.03, but we need less than that. Since we need to less than that, then it has to be less than 0.1%. So it is is very less than 0.1%. We want to be just at a borderline of 0.1%. So we need to increase this probability. For that, we need to reduce the sample size. And let's do 55 here. What do you think will happen? Can you think about it? If we do this, then it should increase the probability. Now let's do around 51. Let's see what happens. It is 0.9. So the probability has reduced to 0.9%. So this is what we're looking for. It has to be at a borderline, right below 0.1%. Not too much, but right below at a borderline. So that's what we did today. So let me quickly summarize what we learned today. We learned about exercise of hypergeometric distribution. For this, initially we started with the CDF of the hypergeometric distribution, and then we use that information to compute a quantile. It also known as a critical value in a z-score in a normal distribution, and then we use that to compute the cumulative distribution for the hypergeometric. So that's all. That's what we did today, and thank you for listening. Have a good day.